Wonderful viewers, welcome to Science and Spirituality on Supreme Master Television. On today's show, we will be taking a look at the ancient art of origami and its application to some of the most advanced scientific and technological endeavors. The word origami is made up of two root words in Japanese, ori meaning fold and kami meaning paper. Some say that origami was originally developed in China by Cai Lun in the year 105. It is thought that in the 6th century, Chinese monks introducing Buddhism to Japan also brought the art of paper folding with them. Paper was highly respected in Japan at that time, as it still is today, because it was used to write down and disseminate the holy teachings of the Buddha. Others believe origami has its roots entirely in Japan. The Shinto religion, which is practiced in Japan, uses in its ceremonies what some consider to be the origins of origami. One example is the zigzag paper designs known as gohei, employed for purification ceremonies by the Shinto priests. What is clear is that Japan is the land where this art has flourished the most and has been refined to the greatest extent. Origami has deep roots in Japanese culture. In traditional Japanese weddings, origami-like butterflies known as mecho and ocho, which represent the bride and groom, are used as decorations to bring good luck to the couple in their new life together. The ancient samurai used to exchange gifts adorned with folded paper known as noshi. The two very popular and familiar origami shapes many of us know are that of the crane and the tortoise. Both symbolize longevity and happiness, and are considered spiritual animals. Since ancient times in Japan, simbarzuru has been practiced. This is a belief that if one makes 1,000 paper cranes, one's wish will be fulfilled. This practice is particularly associated with seeking recovery from illness. Over time, making paper cranes has come to symbolize a desire for world peace as well. For Vesak, which marks Shakyamuni Buddha's birthday in some parts of the world, origami cranes are folded and then sometimes placed in rivers in celebration of the Great One. Origami has not been reserved just for the worlds of spirituality or the arts. It was in the 8th century that paper folding in the Arabic world blossomed, as it was a method used to study mathematics and geometry. Along those lines, today there is a renaissance in the use of origami in science. One may ask, how is this ancient art helping researchers? One notable project is called eyeglass, which is still in the developmental stages. In the early part of this decade, Dr. Rod Hyde and colleagues at the Lawrence Livermore National Laboratory in California, USA, wanted to design a space-based telescope 40 times more powerful than the Hubble telescope of the National Aeronautics and Space Administration, or NASA, which has helped to determine the rate of expansion of the universe and provided many stunning pictures of deep space. As proposed, the eyeglass would be placed about 40,200 kilometers above the Earth's surface. It would consist of a large 100-meter-long paper-thin membrane lens which would focus light onto a smaller normal space telescope located several kilometers away in a lower orbit. However, the engineering challenge is how to get a 100-meter lens into space when there is only 3 to 5 meters of space available for a payload. The scientists at the laboratory decided that they would need to carefully fold the lens so as not to degrade its optical performance. The mathematics required to do this was so very complex that they contacted the brilliant American physicist Dr. Robert Lang. Dr. Lang is not only a physicist, he is also an origami master and is one of the leaders in the origami field of blending the art with the sciences. The scientists needed to use origami to turn the lens into a cylindrical packet that could be loaded into the rocket. It also had to have a finite number of crease folds so as not to affect the lens optical capacity, as well as being radially symmetric. Dr. Lang and the team from the laboratory tried a variety of designs over the months, but eventually settled on a collapsible umbrella design. This was not the first time that origami had been contemplated as a solution for a space project. In the 1980s and 1990s, Professor Emeritus at Tokyo University, Miura Koryo, worked on finding a special fold for use with solar panels for satellites that will be made compact for launching and then open out once in orbit. The fold used had to ensure the stability of the panels. The result was called the Miura-Ori fold in honor of Professor Miura Koryo. The first application of Miura-Ori in space was in 1995 on a Japanese research vessel, Space Flight Unit, to fold a solar power array, or a group of interconnected solar cells. The same technique is now popularly used to fold road maps and tourist maps. In 2007, the National Aeronautics and Space Administration and the Japan Aerospace Exploration Agency collaborated on developing a tether to keep satellites in correct orbit. The result was called Fortissimo. Although the Fortissimo tether is 1 kilometer long, 0.05 millimeter thick, and only 2 centimeters wide, it is designed to be strong and capable of being quickly deployed within only a few minutes. The key for the rapid deployment and packing of the tether involves the use of origami techniques. When we come back, we will find out how origami is helping science to save lives. You're watching Science and Spirituality on Supreme Master Television. Welcome back to Science and Spirituality. We have been discussing how the art of paper folding, or origami, which has both spiritual and artistic roots, is assisting in technological developments that are benefiting our planet. Besides its applications in space, back on Earth, origami is saving lives in more ways than one. In terms of automobile safety, airbags have become extremely important, saving thousands of lives every year. Making effective airbags requires a lot of engineering and science to assure that the bags inflate properly and quickly enough within only a few milliseconds, so that they can provide sufficient cushioning for a variety of body weights from children to adults. Experts in the industry use computer simulation techniques like finite element analysis to try and predict how a bag will inflate and if it will do its job effectively. However, for any simulation to work, the computer must know how the bag will be folded and stored. Folding and storage affect how quickly the bag will inflate and whether any weaknesses will be exposed along the crease lines. Amazingly, an algorithm that origami enthusiasts had created to fold paper insects became a part of the solution in determining as to how to correctly fold an airbag. In Japan, another safety feature of cars is also utilizing the wisdom of origami. Most vehicles today have what are known as crumple zones located at the front and rear of the car. These zones are specially designed to absorb the energy of a collision by crumpling and thus protecting the lives of the passengers. Tokyo Institute of Technology Professor Hagawara Ichiro, who is also the director of the Mathematics of Origami Engineering Research Group, has worked with the Nissan Automobile Company on designing a crumple zone that will absorb the maximum amount of energy during impact. To achieve this end, he has applied his knowledge of origami to come up with the optimal fold pattern. However, it's not just in automobiles that the art of origami is saving lives. Researchers at the University of Southern California, USA, led by Dr. Peter Will, are producing origami on a microscopic scale, half the width of human hair, to help safely deliver medication to patients. The team has designed and produced micro-sized containers in the shapes of cubes, pyramids, pentagonal lotuses, and other forms to provide the body with an exact dose of a medication into the blood. For some patients, taking the precise amount is crucial, as too much of the medication could have dangerous side effects. As with the traditional skill of origami, researchers discovered that by changing the sequence of folds, the properties of the container also change. In 2003, Dr. Karori Karibayashi and Dr. Zong Yu at Oxford University in the United Kingdom developed a medical stent using the principles of the paper folding art. A stent is basically a collapsible tube that can be made very narrow and thus be pushed along arteries and veins or elsewhere in the body, such as a bile duct. Often stenting is carried out to widen narrowed arteries or to allow blood flow where a clot has developed, so as to prevent heart attacks or strokes. The stent must therefore be very small, but at the same time be able to expand to a larger, more stable size. In order to achieve a suitable, expandable stent, researchers turned to computational origami for a solution that used helical folds. Origami can also be found in more day-to-day objects with which we are familiar, such as the geometric indentations on aluminum cans, which give them strength, or the spiral grooves on the sides of plastic bottles, which make them easier to crush so that they can be recycled. With spiritual roots, the ancient art of origami is helping scientists and engineers in numerous ways in devising unique solutions. May the thriving applications of origami create new innovations to advance humanity in constructive ways. Thank you for joining us today on Science and Spirituality. Coming up next is Words of Wisdom right after Noteworthy News here on Supreme Master Television. May art, science, and spirituality continue to uplift our lives.